today I want to demonstrate deploying a 5G core network on Kubernetes using open source mono. Therefore, I will start with the story of network function virtualization NFV and continue with a brief definition of software-defined networking. Next, we will take a look at SBA, and finally, we will get a demo on OSM. In this project, what has been done specially is to separate the Go functions and their separate deployment using the OSM, open source 5G cores, which we have used in this project are Open5Gs and Free5Gc. Also for simulation and end-to-end test, we will use UERANC, and even in real lab, we used Soft Codebox for end-to-end test as well. So let's go through NFV. So what is NFV? As you can see in the picture, this is the overall architecture of the network function virtualization. In right hand we have mono, which especially we are going to use the OSM open source mono as mono, okay? And we are going to use the Kubernetes instead of network function virtualization infrastructure. By the way, let's see what is the story of NFV. It is a way to virtualization of network services, decouple software from hardware, then no need to have dedicated hardware for network functions. What are the values? Use VNFs instead of physical network functions. We are going to use COTS instead of dedicated hardware. So definitely we are going to have better resource management, and even it improves scalability and agility by allowing service providers to deliver new network services and applications on demand without requiring additional hardware resources, providing harmonized services, operations and monitoring, resource consolidation that results in physical space, power and overall cost reduction. So network function virtualization is a way to virtualize network services such as routers, firewalls and load balancers that have traditionally been run on a proprietary hardware. Even you know better than me that mobile network functions, mostly in core part, we used to have the proprietary hardware for every element, but with network function virtualization, definitely we are going to have just COTS, and we can install the containers or VMs on top of them. With NFV, you don't need dedicated hardware for each network function. Definitely NFV improves the scalability and agility of the new services which operators can provide. Okay, as you can see here, we have three types of the network functions, which we previously used. PNFs, which it means that permanent or physical network functions, which we had dedicated hardware for each network element or function. With network function virtualization, we changed it and we are using the just one harmonized type of the hardware for all functions which we want to deploy on the network. And definitely it is telling us that yes, we can use a server, for example a HP server or Dell server, and we can install the hypervisor virtualization layer. Then on top of that we can create virtual machines that we can run the virtual network functions on top of that virtual machines. So virtual network functions refers to virtualization of a network function. VNF provides a specific networking function in a software form factor and can be run on any x86 based server. VNFs are mostly deployed as virtual machines on Linux, KVM, VMware, OpenStack, vSphere, OpenShift, and on commercial off-the-shelf hardware COTS. Virtual routers, for example, provide routing functionality on commercial x86 server, thereby awaiting the need for custom build of hardware box. VNFs are relatively new, and we can use them on any virtualization platform. Then a newer version of the virtualized functions are container cloud native network functions or container based network functions, which refers to the containerized virtualized network functions. Here we don't have the guest OS, we don't have virtual machine which have to install guest OS, and just they are going to be we are going to have container engine instead of the Hyper-Vs. So let's go through the SDN. Okay, SDN means software defined networking. What is it? Uses software controllers that can be driven by APIs to communicate with hardware infrastructure to direct network traffic. It offers the potential to deliver application environments as code and minimize the hands-on time needed for managing the network. They couple control plane and user plane. As you can see in the picture, traditional network control plane and data plane are together, but in the SDN based network we decouple the control plane and data plane. Here you can see that all the data plane nodes can have a big picture, all information related to the entire network, but in traditional networks definitely just neighbor nodes can understand each other, and there was no more information at a specific time regarding the entire network. What are the values? Improve the scalability and agility to provide new services. Definitely network slicing is one of the benefits which SDN can bring to us. Orchestrated operations and maintenance in heterogeneous network. It centralized information so that organizations can view and control the entire network and devices. Multi-purpose usage of one device, fault tolerance, load balancing, and these are some of the values that SDN can bring to our network. And this is the three layer of the SDN architecture, which you can see here. The lower layer is the forwarding layer, which they are controlling by the SDN controllers, and there is a specific protocol between the controllers and the forwarding layer, which it is mostly the harmonized the protocol, and it is not rigid and hard protocol. And on top of the SDN controller, it is the application layer, which we can use the third-party applications, which they are interacting with the SDN controllers via HTTP. It is northbound interface, and mostly they are using the API. And you can see briefly a three-layered service-based architecture. SDN architecture, which exactly we are going to use this architecture in the 5G core. So let's go through the 5G network architecture. Okay, 5G core network has been introduced within 3GPP with 3GPP release 15, which was reference point architecture. What does the reference point means? Reference point mean that every element wants to connect to another element. It should be a point-to-point network between two elements, and there should be a dedicated protocol in between. So most of the time we have lots of connections between elements. Then they should be point-to-point. Also, they have to support dedicated protocol for themselves. So it means that one node can support lots of protocols, because one node can maybe or supposed to have multiple connections toward the multiple elements. This is the hard part of the reference point architecture. Over each interface there are only two network elements with a specific protocol, but SDN brought a magic for 5G network, and it was service-based architecture. Instead of point-to-point interface functions, we use SPI, service-based interfaces. There are no point-to-point interfaces and functions that will connect to the bus, which can be a virtual network. Instead of several specific protocols, all functions will use HTTP to communicate each other. This is the magic of SDN, which it can bring inside the 5G core network. Okay, this is the service-based architecture of the 5G core. As you can see, I've divided in three layers. Lower layer is the forwarding plan, which we have the user praying functions, Gnode, and UE, and whatever external data networks. Maybe they are even, under control of the SDN. But middle layer is the AMF, access and mobility function, and service management functions, which they are controlling the lower layer. And they are right now an N2 interface and N4 interface and even N1 interface are using different type of the protocols, but definitely they are going to change. They are going to be changed. This is the thing that we are going to use the harmonized protocols to simplify the communication between nodes. Okay, but on top of that, Northband interface, which it is the service-based system bus, which we have all kind of the network functions over there, which they are communicating each other over a bus with a harmonized protocol, which we are telling, which we are using the HTTP tool. Here I've put a conjunction between the NFV and SDN. As you can see in horizon, SDN is divided in three layers. I'm in the SPA, providing the SPA service-based architecture. But what we need in the architecture, we need to virtualize the function. So in vertical, we are using network function virtualization to virtualizing our network functions. So this is the time to go to OSM. Okay, what is OSM? OSM means the open source mono. Is an ITC hosted open source community delivering a production quality mono stack for NFV capable of consuming openly published information models and available to everyone, suitable for all VNFs, operationally significant, and virtual infrastructure managing independent, which it means that you can use for all kind of the virtual infrastructure management, even the network function virtualization infrastructure like Kubernetes, like OpenStack, and everything. OSM follows a regular cadence of 2 releases per year, alternating between long-term support release such as release 14 or release 12, 2-year support, and the standard release like release 13, which already I've installed release 13, and soon I will upgrade it to 14. I believe that you find that in which part of NFV we are going to use the OSM. I've told you OSM is open source mono, so definitely we are going to use it for mono. As you remember this part here, we are going to use OSM for this part. Okay. This is overall architecture which we are going to use. As I'm working on the Mac project as well, so based on because of that, for how to say proving the concept of that, I've divided the overall architecture to different clusters. They are real clusters which I've developed. Okay, as you can see, we have OSM cluster, and as you can see, we are using the Free5Gc and Open5Gs. For each one, I've divided them in control, in central cluster and edge cluster, which the edge cluster means the Mac, and just I've put the UPF, user plane function over there, but the rest of the functions, the other control functions are going to sit in the central cluster of each option. So we are going to have, for now, we are going to have 4 clusters for 5G core. Also, I'm working on ORAN, and I'm in between to integrate the ORAN with the OSM, which previously maybe you can find some best practice which they are using the ONAP instead of OSM, but I'm going to do some different things between ORAN and the OSM. Okay, this is a bullet wise the deploying procedure, preparing VMs based on requirements, installing Kubernetes and required packages for supporting it, Jojo and Helm, creating virtual infrastructure manager VIMs, add Kubernetes cluster using Vim to the OSM, provide required Helm charts for NFV VNFs and publish their repository over HTTP. This is the hard part which I've done by myself, which it means that for any individual function of each option, I've created dedicated Helm chart package and even dedicated repository, and I published them over HTTP, because OSM is going to, whenever you want to instantiate the network service via OSM, OSM is going to download the files, the related files from the advertised repository over HTTP, and install the start to deploying the function on the required cluster, specific cluster. Fine. So definitely after that we have to provide the descriptors of VNFs and network services. Then we have to onboard the VNFs and network services. After that, the last thing for deploying the functions, we have to instantiate the network services using the OSM to deploy network functions pods on related cluster. Then we can test it. I have to tell one more thing about the advertising repository over HTTP. There are 3 options here. We can use the public storages like GitHub, Google or Amazon or something, or we can use the Docker container for advertising locally, or even we can use Helm with a specific service of the publishing the repository over HTTP. These are the 3 options which we can use. Now I've used GitHub pages to publish my repositories over HTTP. Okay, this is entire architecture. This is exactly logical architecture which I've deployed. Okay, you can find it in OSM documentation site as well. This is the Northbound interface. Right now we have there's a portal which it is using the specific APIs between the open source mono system or engine, which is going to control virtual infrastructure managers, and via virtual infrastructure manager it's going to control the network function virtualization infrastructure, and even open source mono is going to manage life cycle of the network functions, which we are going to use container or cloud native functions, because our NFVI is Kubernetes. So let's start the demo. Okay, this is our OSM portal, and as you can see we are using release 13, and you can see our VNFs or CNFs which we are they are active here, and they are about 21. In first page you can see the Vim accounts. These are the virtual infrastructure management accounts. Even you can integrate the SDN controllers to control the network devices as well, but right now it is not part of this demo. We have 21 VNF packages which we already provided for it, and 21 network service packages and 21 network service instances already active here. Okay, we can see the network functions which we have deployed via OSM here. I'm going to show you the clusters as well, but before that let's see something else. Even we can manage them via the this is GUI, but we can use the OSM client on the OSM machine, I mean virtual machine, to control the OSM, exactly see the reports, see the VNFs, NSs, and everything. Okay, as you can see here, I have 4 different virtual infrastructure management account. These are related to different, each of them is related to different cluster. So let's see the different clusters here. As you can see, I have 4 different clusters. This one is for Free5Gc. I didn't change the name. Free5Gc control plane, and this is the edge cluster, which it is related to Free5Gc user plane, and even CP Open5Gs CP cluster and Open5Gs UP cluster. Each of them, each of these cluster are using one of these accounts. I've definitely this is for Free5Gc CP, Free5Gc UP, Open5Gs CP Vim, and Open5Gs UP Vim. So each of clusters are using one of those Vims. Maybe we can have it. There are lots of information here, which we can find those information in the details. Fine. Okay. This is the OSM machine, which this machine is including not just OSM cluster, even Free5Gc cluster as well. Let's see this. Okay, fine. As you can see, these are Free5Gc pods. All of them are here. Fine. Okay, This is the Free5Gc UPF cluster, and let's check it. QCTL get pods on chain spaces. As you can see here, we have Free5Gc UPF, and it is running 20 days. Okay, there is no problem here. So let's back to the dashboard. Even if we have the cluster for Open5Gs and both CP and UP differently, and we can see, as you can see here, this is the one of the pods on the pod on the Kubernetes cluster of Free5Gc UPF, and these are the pods on the for Free5Gc on Free5Gc CP control the cluster. I want to show more thing about the integration between the Kubernetes and OSM here. Let's go forward. So for one of the definitely at first we have to introduce every packages here. These are the VNF packages which I've introduced here. We can see here this is the descriptor which I've provided, and as you can see we have the KDU configuration. I mean the introduction here. Actually this is the NSD. Let me show you the VNF packages. These are VNF packages. Let's see the descriptor. As you can see here, there is a KDU introduction here, which we are using the Helm chart, and as you can see, this is the repository address which we are using for deploying this function. For every packages, VNF packages, we have same thing, that they have different address of the repository. As you can see, I can show one by one, but let's back. Okay, in description, I mean in VNF description, we have KDU, which it is going to mention the address of Helm chart repository. Where are them? The repositories are here. K8's repository. For example, let's one more time see Free5Gc AMF. Okay, VNF package. We can see its name is the Free5Gc _AMF _KNF Kubernetes network function. As you can see here, the address, I mean the name of the machine, the name of function is going to be Free5Gc _AMF, and the address of the repository is this. Let's back to the repository K8 for AMF, Free5Gc AMF, Free5Gc AMF here, Free5Gc AMF. This is exactly the name of the name of the repository, which the folder that it is containing all files required to deploying that function. As you can see here, it is located in my own GitHub, and it is advertising. It is published over the GitHub pages, and here every time when I want to instantiate this function, I need to click on the instantiation key, which I'm going to show you, and it's going to download from this address all packages, all Helm chart packages, then related to this function, and it's going to deploy it. Okay, for last word, I'm going to show you the instantiating, I'm deploying I'm going to show you termination, and then redeployment of a function. So one more thing, that for every VNF we have to identify a network service. As you can see here, this is network service, which it is going to Free5Gc. These are YAML files. These are YAML files which we can write here. As you can see, we can exactly edit here everything. You can write everything here, or even you can use the CLI to upload or onboard this file to the OSM. You can onboard via OSM. There are OSM commands in OSM client which you can use them to upload this file to the OSM. After uploading that file, you can see this configuration or this identification here. For both NSD and VNFD, we can onboard them via CLI as well. Even we can deploy them via the GUI as well. You can write here, or even you can upload file here. I'm using the portal or GUI. So we are going to use Free5Gc AMF KNF. I'm in the VNFD, which it is have to say pointing to the repository, and repository is pointing to the published HTTP, which the files are located over there. Okay, fine. Then after uploading them, you are going to have network service instances after instantiation. Okay, for how to say removing or terminating a function, we have to come instances, and just we have to come here. Okay, Free5Gc AMF. This is the thing that we can, how to say, we can delete. Just you can see this. If I let me make this ready. Okay, let's just summarize the codes of this namespace, which it is related to Free5Gc, and this is AMF, which it is here. You can see here, this is the AMF, which it is here. Okay, and I'm going to delete it, just it. Okay, and let's see, it is terminating. Okay, let's try it. As you can see, it is terminating as well, you know, you can see here. Okay, it is finished, and we are going to see this is if we refresh sometime, it is finished. There is no AMF here, but still we have AMF package, NS package here. You can see here. Okay, fine, just we are going to instantiate it again. See this, I'm going to Free5Gc underline AMF underline AMF, just it, and here descript, these are mandatory. Okay, it is telling me that okay, this is the exactly network service descriptor, which descriptor I'm going to use, so it is clear here. But on which cluster you are going to deploy it, it is going to be on this, because this account is for Free5Gc control plane. Okay, there are something here. We can use YAML file for configuration, or even we can these are extra configuration which you want to do it. If you find, you know, these kind of configuration are going to help us to make portability between the network functions, which you can just have one VNFD or NSD, and just one repository. Which this configuration you can change the IP allocation, everything related to every specific I have to say copy of that virtual network function. and you can deploy it more time which you want, or you can you can deploy it for a specific slice. Okay, as you know, OSM is supporting network slicing as well. There are network slicing templates, as you can see here, net slice template, which we can deploy network slicing as well. But we don't have extra configuration here, just we can create it. Just push create. So it's creating. Let's see here. As you can see, you see AMF is pod initialization running. AMF is running. Finished. So we delete the function and redeploy it. And we will see here after finishing this, it's going to be green. Yeah, done. Fine. On dashboard, as you can see here, Free5Gc AMF is very younger than the other functions. So guys, this is the first part of our demonstration, and I'm going to capture another video for end-to-end test, and I'm going to introduce more. Our masterpiece were just dividing every single function related to Open5Gs and Free5Gc, and definitely we are going to have videos for and trainings for ORAN deployment via OSM, deploying the X apps, rig, both non-real-time rig and real-time near real-time rigs, and even we are going to use OSM as SMO, or service management orchestration. Have a good time, and goodbye.